Okay, guys, here's part 2, continuing with series. Here's an example. This one right here, as you can see, looks like 2 factors in the denominator. As I expand this infinite series, you have that. Well, it is not geometric, as you can see. Even if I divide what number times this one gives me that one, and so on, is the same. No, it doesn't work. Let's just split that into 2 partial fractions. 2 partial fractions. That's what we're gonna do. Here we go. And remember partial fraction, when we do integration with partial fraction, that's exactly what we're gonna do in this case. So find the common denominator, set it equals to 1, the top numerator, and when k equals -4, I get a equals 1. When k equals -5, b equals -1. So I split it in 2 sigma notation, and when I expanded, I noticed that the one is 1/6, it repeats 1/6, one with a positive and one with a negative, and so on, as you can see in the middle. This is the open form, which means every term in between cancels except 1/5. So it means that this particular type of series is called telescoping. Telescoping. Why telescoping? Because those type of telescope that is like looks like a cone, but you can shrink it and expand it. That's basically what's going on in here. That's why they call it telescoping. So this converges to 1/5. So not all telescoping series converges, by the way. But let's see what happens then. So we know that this is the expansion, and the nth term is this one, n plus 4 minus n, which are these. You notice these 2. And then in between, that's the sum, adding all those together. In between, they all cancel. Even this one cancels out, because the previous one to this one is going to be negative. So these 2 cancel each other's out. So the only ones left of the total sum is 1/5 and 1 minus 1 over n plus 5. That's the closed form of the sum. So I'm going to take the limit, and here's the limit, and turns out to be 1/5. So the sum is 1/5. You see? Not only converges, but the sum is 1/5. This is called the telescoping. So generally, most of the time, when you're gonna solve the telescoping series, it's gonna be in this form, something like this. It could be 3 or 4, but usually you put 2, not many, and you make it into 2 partial fractions, and you'll be able to find out through the calculations and collapsing all those terms in between and finding the limit, you'll be able to find the sum. So that's the other one besides the geometric convergent series, the telescoping, that you'll be able to find the sum. Okay? Okay. So another example, look at this one, is this is another telescoping in the open form. The ones in between, they start collapsing. So you have this -1 and the last one n plus 1, and is equals to n. When you apply infinity, n goes to infinity, is infinity, diverges. So not all telescoping series converge. Not all converge. Sorry, this should be converge. Not all of them converge, so this diverges. Okay? We'll cancel this out. Alright. And the other one I want to mention is the harmonic. So let's stop here, because it's taking a while to download. So I'm gonna download the one about telescoping, and then I'll do the one with harmonic.